Today, we will learn grouped frequency distribution. Your school must have a fitness test every year. A fitness test was also taken at Adarsh Public School, in which the pulse rate of 100 children was thus obtained. The numbers collected for any information is called data. But it is not easy to get information from this data easily or draw any conclusions. Such data is called as raw data. To understand them, we can arrange them in ascending order or descending order. Pause the video and arrange them in ascending order. Is it easy? As the number of figures increases, it becomes difficult to organize them in any order. Another way of arranging these is that we create a table and write the pulse rate in first column and show how many times the pulse rate is repeated in the second column as tally marks and write the number of the tally marks in the third column. This number will tell us how many times the pulse rate is repeated in the data. The number of times an observation is repeated is called the frequency of that observation. For example, the pulse rate of 3 children is 61. We say that the frequency of 61 is 3. By arranging the data in such a way, we get the frequency distribution table. Since data groups are not created here, this is an ungrouped frequency distribution table. Since the data here are many and varied, the frequency distribution table will be longer. It will also be difficult to make such a table and get any information from it. In such a situation, we can make them smaller by forming groups of data. The smallest number in the given data is 61 and the largest number is 99. In this way, the range of data is from 61 to 99. So we will condense the data into groups in such a way that the numbers greater than or equal to 61 and less than or equal to 99 are included in them. Here we can make groups like 61 to 65, 66 to 70, 71 to 75, etc. We call each such group a class or class interval. The smallest number in a class interval is called the lower class limit of that class interval, and the largest number is called the upper class limit of that class interval. The difference between the upper class limit and lower class limit of a class is called class size or class width. Keep in mind that the size of each class interval is the same here. Now we will represent the data falling in these groups by tally marks. The first number is 74, which will be included in the class interval 71 to 75. The second number is 61, which will be included in the class interval 61 to 65. Similarly, we will represent all numbers as tally marks. By counting the tally marks, we will know how much data is included in each class interval. That means, what is the frequency of each class interval? This type of table in which the data is grouped or organized by grouping is called a grouped frequency distribution table. Now, we can get information from this table more easily, like the pulse rate of 25 children is between 71 to 75. We can also form groups of 60 to 65, 65 to 70, 70 to 75, etc. To organize the given data, let's organize the data into these groups. The first number is 74, which we will include in the class interval of 70 to 75. The second number is 61, which we will include in the class interval of 60 to 65. The third number is 65. Can you tell in which group we will include it? Think. Here we see that the number 65 can be included in these two groups, 60 to 65 and 65 to 70. But if it is included in both, then it will be counted twice, which is wrong. To avoid this, we follow convention. The common or overlapping observation between two intervals is considered in the higher class interval. In this way, we will include 65 in the 65 to 70 class interval. Similarly, we will group all the numbers. In this way, we will also get a grouped frequency distribution table here. Let's compare the first table with this table. Do you see any difference between the two? Think. Let us tell. None of the two classes in this table have overlapping lower class limit or an upper class limit. That means that classes are not overlapping. Such classification or distribution of data when the class is non-overlapping. This is called discontinuous frequency distribution. In this way, it is a discontinuous frequency distribution table. If we talk about this table, then there is overlapping of the classes in it. That is, the classes are overlapping. Such a distribution of data is called continuous frequency distribution. This gives us a continuous frequency distribution table. Today we learned grouped frequency distribution. In the next video, we will solve some interesting examples related to them.